Galileo's approach to science was innovative and revolutionary. In an age of superstition, he was bound to arouse suspicion. But in using mathematics to solve the problems of physics, and in his geometrical and numerical analysis of the way the world works, he set the pattern for research to the present day.
Galileo Galilei, protesting the common knowledge. At the turn of the 17th century, Italian astronomer Galileo Galilei would take the theories of Nicholas Copernicus, a Polish astronomer in the 15th century, and Johannes Kepler, a German astronomer in the 17th century, that the sun was the center of the solar system, and prove them right beyond any shadow of a doubt. He did this with a new technology that would change the course of history. This technology would be known as the telescope, a tool that would help him provide concrete evidence that the Earth is not the center of the universe, against the Church's teachings. The idea of a geocentric universe was discovered by Ptolemy, who was a Greek philosopher present in 100 AD. Later, he would create a model of the geocentric universe, which is widely accepted for over 2,000 years.
The geocentric model tried to explain them using epicycles. These are imaginary points that were moving in imaginary circles with planets orbiting around those points. And it sort of worked, though eventually they had to draw more circles around the circles to explain some things and have the planets move faster or slower at certain points in their orbits. Diagrams of the sky were kind of a mess.
Due to this, Nicholas Copernicus created what he called a heliocentric model, in which the sun is the center of the universe, that went against the common knowledge which has stood for 2,000 years.
Copernicus realized that the math was a little simpler if you just had Mercury, Venus, Earth, Mars, Jupiter, and Saturn, the only planets we knew about at the time, orbiting the sun with the moon orbiting the Earth. He used epicycles too, but all the planets in his model kept the same speed throughout their orbits, which is what you'd expect if the orbit is a circle.
Because Copernicus has set the precedent for Galileo, he was then able to refine his telescope, which would later allow him to prove Copernicus correct in his discoveries. Later, the German astronomer Johannes Kepler would discover Copernicus was wrong, and the fact that the shapes of the orbits of the planets were not what Copernicus proposed they were.
Kepler realized that orbits didn't have to be circles, and if he assumed that they were ellipses, the math fit the motion of the planets, sun, and moon a lot better using the heliocentric model.
Kepler would then go on to create 3 laws of planetary motion. His first law was that the planet moves in an elliptical orbit around the star, which stays at one point. His second law, the law of equal areas, which means that whenever the planet is on its orbit, no matter how far or close it is to the star, it will travel at a constant speed. His third and final law is the law of harmonies, which states that there is a proportional ratio between the square of the planet's orbital time and the average distance from its star cube. Using the model of a heliocentric universe that Copernicus had created, and the 3 laws that Kepler had created, Galileo, with the help of his new and improved telescope, would then go on to teach and spread heliocentrism, that the sun was the center. To spread his belief, Galileo published a book known as the Dialogue, concerning the 2 chief world systems. Knowing the Church would rebel, inside the Dialogue, Galileo stated 2 arguments, the one in which he believed was correct, heliocentrism, and the widely accepted geocentrism. Once the Church found out about Galileo's newly published book, it appeared to undermine Scripture, dangerous for a church that fell under siege, dangerous for an astronomer opposing it. To stop these seemingly unlawful actions, the Vatican gave Galileo a warning that the next time he opposed their power, he would be sentenced to death. Knowing full well that he could be executed, he still decided to build and test multiple telescopes, each with a different magnification. Through one of his new telescopes, Galileo plainly saw that Venus went through phases, like our moon, clear evidence that the sun is the center. With his new discoveries, Galileo published another book known as The Starry Messenger. In it, he explained the phases he saw and many other small details. At first, the Church welcomed his new discoveries, not knowing if they did support this, it would be their downfall. They finally realized the true potential of what Galileo published, and he was tried. He was then found guilty of treason and sentenced to death. Due to his old age, he was instead put under house arrest. Still, even under house arrest, Galileo wrote in a journal about his discoveries, which would not be made public until 200 years after his death, when the Church finally admits to their wrongdoings. One of the greatest ways Galileo defied the common knowledge was known as the Leaning Tower of Pisa experiment. Ancient Greek philosopher Aristotle was alive around 300 BC. As far as we know, he did not actually perform any experiments of his own, but he did observe the world and believe that logical thought alone was enough to explain the rules of nature and physics.
For Aristotle, taught that heavier objects fall faster than lighter ones.
To prove this right, without performing an experiment, he justified that an iron ball would fall faster and hit the ground before a wood ball. While this seems logical in the sense that an iron ball is way heavier, this just simply isn't the case. To help Galileo prove this is incorrect after his death, Isaac Newton, an English physicist in the 17th century, helped prove the laws of motion and falling objects to be faulty in its current state at the time. What Galileo had said to help future physicists was that weight was not a factor in its fall, instead its mass. Up to this date, many physicists have proven this to be right and Aristotle to be wrong by using a feather and a ball or hammer. This is only done in a vacuum, which in a vacuum it takes all the air resistance out of play. One of the many ways Galileo was proven correct in his theory was called the Apollo 15 hammer feather drop. At the end of the last Apollo 15 moonwalk, Commander David Scott performed a live demonstration on how a feather and a hammer in vacuum played out while falling.
Well, in my left hand I have a feather, in my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his...
According to traditional account, to refute what Aristotle had said about heavier objects reaching the ground first, Galileo dropped two balls of different weight off the Leaning Tower of Pisa. Both balls hit the ground at the same time, which went against what Aristotle had said and taught for generations.
Now the black one clearly feels a lot heavier. So the standard misconception is to believe that the black ball will accelerate at a greater rate and reach the ground first.
Galileo now had proof that it wasn't about weight, it was about the mass and the air resistance on the object.
All right, ready? 3, 2, 1.
Now, gravity just doesn't have an impact on balls, but all falling objects has air resistance, like feathers and parachutes. All have air resistance. The only time where air resistance does not occur is in a vacuum, or more simply, in space. In space, there is zero gravity, which means no force is applied to objects, no air resistance. This is known as free fall, which mass and weight has no effect in, which results in a feather and a hammer landing at the same time. Galileo Galilei, the father of modern astronomy, stood up against the common knowledge in such a way that no man before him had. Before his time of house arrest, even being a devoted Catholic, still believed that it was not right for the Church to be treating the ways of science the way they were. Using the knowledge of Copernicus before him, he was able to state that the earth revolved around the sun, which no man before him would dare say due to the cruel punishing that would await. Even after his death, Kepler and even Newton would use Galileo's ideas and prove them right, while proving the ancient scripture to be wrong. During his time, he performed many experiments, such as the ball drop experiment. While doing this, he proved Aristotle's well-known theory of heavier objects falling faster to be incorrect. Galileo proved, Galileo saw, Galileo revealed many things, still of which are used in modern science and astronomy today. He rightfully gained the name Father of Modern Astronomy by proving the widely accepted theories to be inaccurate, while setting the foundation for a more accurate tomorrow.